All right, you guys, morning. So today's lesson, we're going to be doing surface areas of Frustums. That's something that's new, and I'll introduce what that is. It's only me showing you two examples, and then your homework, which is the rest of your worksheet, has a mix of frustrum problems and composite pictures. These are a little bit more challenging. You're going to have to just try the best you guys can with them. So these would be your challenging problems. This one is challenging. I'm not going to do it because I'm not going to waste the time because obviously I'm taking away some of your challenging things. But if anybody does this surface area problem and you want to know what you should get as your final answer, you get 99.5 centimeters squared. You have to find the surface area of everything, but what you'd want to think is if you're wrapping a present, you have to cut this hole, because this is going through, out on the rectangles, and obviously just think this is one thing, so there's only one area, one base. But if that's up to you. All right, so let's write what a frustum is. Frustum, good if I can pronounce it. A frustum is a portion of a solid, and the solids that we're going to be using are going to be a cone today, and when I teach you pyramid, also then we're going to do it with pyramid. So it's a portion of the solid that remains after its upper part has been cut off by a plane parallel to its base. So let me explain and show you guys what I mean, what I'm talking about. So if you guys take a look up here, so pretend here's a cone. And then what you're going to have here is, here's some kind of plane. And this plane, which is parallel to the base, cut off, let's just say, right here. And so what ends up happening is once I cut that off, you now are going to have this type of shape. But picture, if I cut this off, what's happening up top here, you're still having this somewhat of like a circle there. So again, this is cutting it, and I'm removing that top. And this whole thing right here is what we call our frustum. Okay, so that is what we're working with. So picture this is gone. Here's our frustum. So obviously here are two bases. They're circles. They're not the same size. Okay, so let's take a look at our problems. So here's the first problem. So here's your frustum, and here's 15 inches. This right here is 5. So this right here, let's make sure we know this, if you recall from your cone, is your lateral, well, my fault. It's called your slant height. I would get that right if I had that one. And that's the radius of the top. So what I want you to picture, if you want, just to, again, have an understanding, because you're going to need this, is extend this up. Okay, and that's what our picture is. And this is what you're trying to find, the surface area. Now be careful. You want all of this. You want the base. You also want the base. So why don't we write how we would do this? Because there's nothing to find this. So here's what you're going to do. If I took the surface area, SA is your surface area of the big cone. So I'm going to take your surface area of the big cone because that's going to include the bottom, and that's including everything. Okay, and then think about this. I want to get rid of that. So if I want to get rid of that, you'd say, okay, let's minus, this is also a cone up here. So we want to minus. Now, what are you subtracting? Do you want to minus? Do you want to subtract this? No, you're just getting rid of this. So that's, you're going to subtract the lateral area of the top cone. You're going to do this for all of these problems, and as always, I recommend you guys doing that. But what about this right here? We want that top, because what you have here is when you did the surface area of the big, you included all of this. Now I just cut off this. I want to also wrap that. So you want to add the top circle. It's the best way I can kind of explain how to do these for you guys quickly, I should say. All right, and then what I recommend, obviously, as well, is just writing your formulas and you're inputting the values. So if you remember surface area of a cone, it's pi r L plus pi r squared, one of them, minus lateral area, pi r L, plus the top circle, which is just pi r squared. That's it. All right, so let's see what we have for our values. So we have pi, okay. The radius of the big cone is this. Great, 15. Slant height, yes, thank God they gave me the slant height. It makes my life very easy. However, we have a problem. Do you have the slant height of the big cone? No, you have the slant height only of this. What we want is we want the slant height of the big cone. So the question is, and that's something that we'd have to figure out, and that's the only thing that really makes the problem, I guess you could say, a little challenging. Watch how we're going to do that. I'm going to put, no, I'm not doing that. Sorry. What we have here is you're going to be dealing with, if I kind of do this like this, we have similar polygons here. So when you have something that's similar, what I can do is I can set up a proportion. Okay, so what I'm going to do is I'm going to make this upper part X. So now what I can do, and I'll just star this, you're going to have to set up a proportion. I spelled that wrong. Proportion. Good if I could spell. Early. Okay, so that I'm going to star. I'm going to highlight that because that's going to be the thing that we have to make sure you know how to do. And that would be maybe your hardest thing. Well, watch how easy. Once you guys know you have to set up a proportion, you're going to go X over my radius of 12. So the slant height of the top over the radius. Now, here's your other kicker. You cannot do 5 over 12. This 5 is random. If you guys remember when we did right triangle proportions or similarity, you need this whole, because this 15 is the radius of the whole cone. So this needs to be X plus 5. I'm just going to highlight that because that's something that we could also perhaps make a mistake. You need the top to the radius, then you need the whole to the radius of the whole thing. Okay, and then we just cross multiply. So that again becomes your hardest thing. So you have 15x equals 12x plus 60. You guys solve it, you should get x equals 20. Once you have that, you're on the right track. So again, that's really important. But think about this. 20 is here. And I want the slant height of the whole cone. So we have a 20 and a 5. So that is where, if anything, what makes the problem a little bit more challenging. I'm going to do another one so you understand it, but let's just review that one more time. So when you're trying to find the slant height, we're taking the proportion. You're going to do x for the top over 12, and then x plus 5 over 15. And that will find you, this, and then you guys can just add it together. So please make sure you're okay with that. And then, plus pi, my radius of the big, is 15 squared, minus pi, the radius of the top, is 12. The slant height of the top is 20. See how helpful this is? You're just not really having to think. Plus pi, the radius is that radius. I need to use this one because that's of the top. Okay, and once you put that all in your calculator, we're going to find exact. So that means put everything but pi and attach pi at the end. And here's what you get as your answer if you put all of that in. 504 pi inches squared. So just stare at that for a second, see if you have any questions. Hopefully that made a little bit more sense. Or hopefully I should say the next one will make some more sense. All right, so this one, let's take a look. All right, so this is 9. So for this one, we're going to find the surface area of the frustrum to the nearest 10th. Okay, so let's do what we did for the other one. Let's write our heading. And I'm going to go like this, so maybe visually it helps you. So we are going to find the surface area of the big cone minus, you got to get rid of that, which is your lateral area of your top. But you want to bring this back in because you want to wrap it, so plus your top circle. Again, hopefully that makes sense. All right, let's put our formulas in there. And again, it's just really helpful to guide you. So pi r L plus pi r squared minus pi r L plus pi r squared. And now we're putting in our numbers. Okay, let's see what we have in this problem. So we have pi. The radius of the big is 12. Now my slant height, L is my slant height. That's the challenge in this problem because that is my slant height. The 7 in this problem is your altitude. So I'm going to start this one. This is going to make it a little bit more challenging. Okay, so watch carefully. This is how you're going to do it. It's a little bit more hard. It's kind of like what I want you guys to think, and this will help you. Think about this as the trapezoid. Remember when we did trapezoid and you wanted to find, let's say, this part of the trapezoid? This is what we would do. We would bring this down. If this is 9, this is 9, this is 7, this is 9, then left over is 3. Then we would do Pythagorean theorem. So we would do 7 squared plus 3 squared equals x squared. 7 squared, 21. Nope, 7, sorry. Wow, that was bad. 7 squared is 49 plus 9. X squared equals 58. So x equals the square root of 58. I know it's a little bit harder. Leave it alone. Don't round because then you're rounding too soon. So that found you that. However, remember this L is the slant height of the whole cone. And whenever you want to do that, if you remember, you're just going to do a proportion. So I'm going to put X here, and we're going to set up the proportion. Your numbers might come out ugly, but it's the same concept. I want you guys to be okay with doing similar concepts. Okay, so we have X over the radius of 9 equals X plus rad 58, your whole thing, over this, which is my radius of 12. Okay, I know it looks funky. Watch how this one works. 12x equals 9x plus 9 rad 58. I'll finish solving this one out for you because it's a little bit trickier. And then we're going to divide both sides by 3. So in the end, 3 rad 58 is for this top part. Okay, so what's the length of the whole slant height? If this is 3 rad 58 and this is 1 rad 58, then the whole slant is 4 rad 58. Remember, you do not add the radicals underneath the radical sign. Plus, okay, now the rest of it should be pretty simple. Pi, the radius of the big is 12 squared. Now we're on to the lateral. The lateral one is the top one, so pi, the radius was 9. Your slant height here was 3 rad 58. And then plus, we're going to add this circle back. So we have a pi, and your radius is 9 squared. Once you put that all in your calculator, I'm going to have you guys round to the nearest tenth. And you get 1,209.3 centimeters squared. So it is complicated, but I think by me showing you it to you the first time, it shouldn't be that terrible. Every time do this, and then every time put your formula, and then try to figure out your values. Remember, whenever you're looking for this, you're going to be setting up the proportion. But you want your slant height. So if you don't have the slant height and I give you the altitude, you're just going to set this up as you would for the trapezoid, bring this down, do Pythagorean theorem. Then you, again, get your proportion. You're going to take the top lateral over the top radius, and then you're going to take the whole slant height and put it over the big radius. And then you guys are going to solve your way through. Okay, so hopefully that made sense. Again, I know it's complicated. I guarantee if you try it and you do it a few times, it's not that bad. The numbers might seem funky, but you'll be fine. So the remainder of your homework for tonight is this worksheet. Please try the best you can. It's a mix. Like here's your triangular prism. Here's your hexagonal prism. For this one, you're cutting out the center. Remember, when you're cutting out something, you're going to want to try to figure out how you're wrapping this. So for this one, if you think about this, you want the lateral area of the cylinder. You also want the surface area, you also want the areas of the top circles. However, you want to cut out these circles. So if you think about this, you want to do the surface area of the cylinder. So I'm just going to kind of help you out a teeny bit for this one. You want to do the surface area of the cylinder. You want to minus 2 circles, right? You want to minus the 2 circles that you're going through because you're not covering these areas. Now, however, here is the catch with this one. Because you're wrapping, you want to wrap all of this inside it. Picture this is inside. You're covering this section. Well, what section is this? This section is the lateral area of the inner cylinder. Okay, so hopefully you guys are watching this and making note of that one. Then obviously for this one, you want the surface area of the prism. This is a hole. So here you guys go. Surface area of prism minus, you have to get rid of this hole because you're not covering it, minus 1 circle. And then if you think about it, plus lateral area, you could say, of a cylinder, but you have 1 circle on right here. So again, this circle you're subtracting is this. You're taking rid of this on the prism. If you think about it, this circle, you're cutting out a circle to go on the prism. Think if you were wrapping this, you would wrap, 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 and then you have to cut a hole. This one's pretty simple. Here are your 2 frustrum problems that you have to kind of look at. Frustums, I get it right. Use your notes. For this one up here, you have to do careful. It's similar to that other one. This one's tricky. For this one up here, you have to do the surface area of the actual prism, same as the one you did here. You want to minus these 2 rectangles, right? Because you want to cut a hole. Then you want it plus the lateral area of the inner prism. Again, hopefully that makes sense because you have to cover the inside. You're not going to leave the present with a hole. And then for this one, you want to find your surface area, and then you just don't want this. So remember, figure out what 72 of 360 is. That's how much you have of this outer. But, so it's 72 over your 360 of your cylinder. Correct? That's everything. However, plus you have to cover these 2 rectangles. So since I explained all of that, the worksheet should be pretty simple. Hopefully you were fine with learning the frustums today. Again, I know it's a little bit more challenging, but try the best you guys can, and I'll give you guys the answers, and hopefully I'll see you guys with questions. Okay, bye!